Are your people aware that they are supposed to join?
Yeah, they are aware, but they are not online.
So why is it that they are not with us?
I'm trying to call them, but I can't reach them. I don't know why.
Salome, did you also
Say,
inform your people that? Did you also inform your
yes,
people?
yes.
So why are we finding a challenge for students to join it? But in any case, we are going to start our lesson today.
Mm,
Doreen, do you have
Okay.
the model?
Yes, please.
Okay. So today we are going to, I'm trying to share, but it looks as if I'm getting
mm,
a challenge. But
yeah.
let me
So
try the,
we have
yes.
the model.
Okay.
We have the model.
Okay. Right. Once you have it, let us all go through together. So today we want to start with unit 1. And
Mm,
unit 1 is about concept formation, the meaning of concept. So if you read your model, we'll talk about explaining what a mathematical concept is. So in mathematics, actually, when we are teaching, because this course is methods of teaching primary school mathematics. When we are teaching mathematics, one of the subject matters in mathematics is concept. And it is taking most of the topics in mathematics. If the child doesn't get the concept well, then it is difficult for the child to understand what you are teaching.
mm,
But you cannot give a concept to the child. They have to abstract their own concept. So if you're a math teacher, you need to help the child to be able to grab the concept right at the beginning. While the wrong concept is grabbed, it will lead them through. So when we talk of concept in mathematics, Richard Kent talk about concept formation. And he said that when we talk of concept, in short, it is the mental idea you form about something. So the moment we talk about something, you yourself find some mental idea, image about something. For example, let me give you a typical example. When you say New York City, you have not been to New York City before. But the moment I talk about New York City, your mind gets to a place you think and you form a picture, mental picture of New York City. And that mental picture you have formed about New York City is the concept you have formed about New York City. So it could
yes.
be wrong, it could be right. And therefore, we need to help every child in mathematics to make sure that everything we are teaching, the right concept is formed. For example, I'm teaching triangle. And the mental image or the mental picture the child will form about triangle is what will lead the child throughout. So SCAN describe concept as the mental object. And that happens when we abstract a number of examples. That brings some commonness. So what it means is that, let me give you an example like we are teaching 2 to a child in class 1. What is 2? The concept of the number 2. Now, if I want the child to understand 2, I have to use different objects that constitute different example of 2. For example, I take 2 books, 2 bottles, 2 pens, 2 pencils, 2 chairs, 2 girls, 2 bags. When the child see, I say, this is 2 bags, this is 2 pencils, this is 2 books, this is 2 girls. The moment I am doing that, then the child will think that 2 is not the book,
Mm,
2 is not the pen, 2 is not the eraser. But what am I seeing common in all the objects that you are bringing? It is the quantity, some quantity. So it could be houses, it could be cars. If we get that quantity, we say it is 2. Then the child has grasped the right concept in mathematics. But if I pick only 2 pencils and show that this is 2, some of the children will get a wrong concept, thinking that 2 is the pencil. So if you talk of 2, they are thinking of pencil. So Richard Kemp just talk about concept is a mental representation of common properties or regularities abstracted from isolated experiences. So what it means is that to get a concept in mathematics, you need to help the child to see different examples and situations. And the child will abstract, means that the child will be able to grasp the common thing to give it the name. Let me give another thing. We are teaching the child concept of red. Now, when I take
Say,
pencil,
say,
yes,
hello, say. Please,
yes,
with the model I'm having with
mhm.
Unit 1, the first topic is pre-number work.
No, you are using the old model. So let
Oh,
me
okay,
share
that
this
was
one.
what was given to us.
Let me share. Okay, Doreen, which model do you use? Hello, Doreen. Oh, he's not with us.
Hello, sir.
What in your model? Which topic is Unit 1?
Sir, it is the concept about what you are talking about. Concept meaning.
So, Salome, let me share that one with you quickly.
Uh-huh.
Oh, okay.
Let me
Yours
share
is
that.
the old one. Salome, yours
Yours
is
is
the
old
old
one.
one.
That was what they gave to us.
No.
But if
The
The
you
math
go
top
to
of
method
the
over there.
LMS,
Yeah,
Salome,
the
if
math
you
method
go to
over
the
there, there are
LMS,
plenty.
if you go to the LMS and you download the model, you won't get that one, you get a new one.
Yeah,
uh,
yeah. The math
So you
method
go
over there,
to
it
the
is more than
materials.
three over there. So you search for yours.
Okay.
uh,
So
Yeah.
I've shared that one
So
with
search
you,
for it.
Salome.
okay, thank you, sir.
So explaining how we can abstract from a number of examples or instances what they all have in common. So I was giving another example like red. Now, if I'm teaching red and I show a red bag to a child and I say this is red color, I'm not teaching the child the correct concept because some of the children may think that red is the bag. But I have to bring a color, a pen, which is red, a book, which is red, a shirt, which is red, a phone, which is red. So many different red objects, but with the same red color. Then when I say red, the child will be able to abstract what is common from them. And that is how we teach concept. So when you are teaching concept, for the child to be able to get the right concept, use as many examples as possible before the child will get the concept right. So this is basically in mathematics concept, this is what we are saying. So if you come to section 1, you ask him explain the term concept in mathematics. And you say concept, you are talking about the mental picture or the mental image or the mental object a child finds about anything you are teaching or any object. The image you form in the mind. So when you go to your model and you read, we talk about the 1.2 said when we focus our attention on the common property of a set of objects, we are abstracting. So the word abstracting means you are pulling out, bringing something common. And so you cannot teach concept without allowing the child to do abstraction. So in the concept formation, you hear the word abstraction or extracting. And this is what the child is seeing as common. He will abstract it. He will abstract, means you pulling it out. So when I see red bag, red book, red pen, red pencil, red phone, and you are saying they are all red, what am I pulling out? Is it the object? No. So red can be any object, but what I'm seeing is this color. So it's the color that is called red. So if you are teaching two, you bring so many objects, telling the child that this is two pencils, these two books, these two guests, two chairs, two tables, and the child will abstract that. What is common that you are mentioning two? It is the quantity. And that is how we teach. So let me, are you okay with the model now?
Yes, please.
So we talk about give and explain 3 different examples of mathematical concepts you introduce to the primary. So if we even talk about color, triangle, and 2 or number 3, anything that rectangle, they are all concepts. But how the child will form that in the mind so that people will not get wrong concept. And that is very important. Any question before I continue?
No, please.
So then we come to the 2 main types of concepts. Richard Skem put concept into 2. He said we have primary concept and we have secondary concept. What is a primary concept? Now, when you want to abstract the concept, we basically use our senses. When I say something is 2, how will I know that the quantity of mangoes or pens on the table is 2? How will I know that there are 2 objects there?
Unless you count.
Or unless you count. Okay.
Yeah.
So if I give you 2 objects and you want to know that they are 2, because they are not many, do you have to count? Let me put 2 oranges there and ask you, Doreen, how many oranges do you need to count?
No, you can just see.
No, please. I can just say it.
You can see with your own eyes.
My yeah.
Good. So if I tell you this is a triangle, you are looking at how many sizes? 3 sizes. You only use your eyes to count, and you know that, oh, it is triangle. So one type of what do you call it? Concept or primary concept is that in the primary concept we are using our senses. Let me tell you another thing. If I say this object is color red, you won't count, but you'll be able to use your eyes to see that. When I say this something is bitter, it's a concept. But the concept is that when you take this type of orange, it is always sweet. How will you know that it is sweet? Unless you taste. So sense of taste. Yeah. And the child will now conclude that this type of orange is always sweet. He has formed a concept about that orange, that it is sweet. In other words, when I take something like lemon, I don't know, lime or lemon, I don't know the difference. The small ones, is it lime or lemon? The small ones are lime, am I right?
Yeah, lime.
So you know, if you want the child to know concept about lime, how is lime looks like, the child will taste it. And the child will know that this is the taste of lime. So the tasting will let the child know the concept of it. So all that concept that you use your senses to be able to understand, or so how will you know that something is hot? When I put a coal pot, I heat it. Anytime a coal pot is heated, what is concept do you form about it? It is hot. How will you know that it's hot? You touch it. So when you touch it, you know that anytime you have heated a coal pot, it is hot. The child has formed that concept. I won't touch it because it will burn me because it is hot. He has formed the concept. So if you go back to, he said, primary concept are concepts that we learn through our experiences or interaction with our environment. So as we interact with the environment, our experiences, and they are directly obtained from motor or our sensory experiences of the outside world, like the 5 senses. So any concept you form from your own interaction with your concept, either you touch, either you see, either you smell, either you hear, all of them are called primary concepts. So how many oranges? To know that it is 2, 2, 3, all the individual digits that we have, 2, 3, 4, 5, they are all primary concepts. The color I use, how do you know that this is red? You use your eyes and know the color, it is red. You use your eyes, you say that he's wearing a white dress. How do you know that this thing is very bitter? You taste. Now, when you are using your senses to obtain these sense concepts, we say that they are called the primary concept. Examples of primary concept are all the color, red, blue, green, whatever. And then the numbers 2, 3, because individually you will see, use your eyes or you touch it, hot, cold, and so on are all primary concepts. So the concept 3 can be formed by seeing or experiencing many groups with 3 objects, like I've explained, and recognize that there is a common property that cut across them. For example, so that's why I say if you are teaching a child, either early grade, primary, KG, and you are teaching any child concept of 3 objects, you don't just write a 3 on the board. If you write a 3 that we write on the board is called the numerals for 3. They are called the numerals for 3. So the symbols we use for these numbers are called numerals. But the concept of the quantity you form in your mind is the number. So please, let's take note. There's a difference between the numbers we write on the board, the symbols. The symbols are not numbers in mathematics. The symbols are not numbers. The symbols are called the numerals. And every concept, every number can be represented by symbols. There may be one concept of number 2, but the symbols can differ from place to place. So even if somebody write I, he has represented 2. If somebody write the normal 2, Hindus Arabic 2 that we write, somebody can give 2 strokes showing it is 2. But what is the idea? So the Babylonians, even the Chinese have a way of writing their 2. But if you write it and say, go and bring the quantity of 2, and somebody who is using our numbers to also go and bring the quantity of 2, we are all bringing the same quantity because we understand it as the same concept. But the symbol we use for them are different. So a number can be the same idea, but different concepts. So the idea is the number, but the symbol is the numerals. Praise, are you okay with that?
Yes.
Okay.
Please.
So in mathematics, we say that concept that we use our senses to be able to identify them or abstract them when the commoners are there. For example, I see 3 oranges, 3 books, 3 pens, then I say it is 3. What am I seeing common, abstracting, pulling out is the 3. And so the 3 is not an object, but it's a concept I have to get. Now, when we come to secondary concept, the second one, it is when we put the primary concept together and we give them a common name. For example, 2 is a primary concept, 3 is a primary concept, 10 is a primary concept, 20 is a primary concept. Individual things are these primary concepts. When we put them together, we say they are numbers. They are what? Numbers. So even though 2, 3 are primary concept, they form a category called numbers. So the number becomes the secondary concept. Now let's come to red, yellow, green, blue, white. What are they? They are different things, but when we put them together, we say they are colors. So a color is a primary, a blue, a red, a white is a primary concept, but color is a secondary concept.
Okay.
Now let's come to triangle. 3-sided figure is a triangle. 4-sided figure is a quadrilateral. When we put them together, we talk about maybe shapes. And so these are, so when we come to your model, we are talking of secondary concepts. He said they are derived from other concepts. So it is other concepts put together to form them. So they are built up by combining primary concept. So when you are talking about the difference between primary concept and the secondary concept, primary concept are concepts we derive from our senses or our interaction with the environment. But when you put or combine these primary concepts together, they form another concept called secondary concept. For example, by considering 1, 2, 3, and so on together, we form the concept of numbers. So once 1 is a primary concept, 2 is a primary concept, they put together to form a number, which is a secondary concept. And red, green, yellow, blue also together form a secondary concept called color. So example of secondary colors are numbers, color, and shape. Like I told you, rectangle, triangle, pentagon, all of them put together, we say they are shapes. But individually, they form primary concept. So we are now also moving to understand that multiplication is a secondary concept. Who can explain why? Because when you are finding 3 times 5, you can say 3 plus 3 plus 3 plus 3 plus 3. How many times? 5 times. When you put 5 times together, even though addition is a primary concept, but when we are putting a lot of addition together, and the numbers are also primary concept, putting them together, you are forming another concept called multiplication. So multiplication is a secondary concept being formed from that of addition. And so secondary concept depends on other concepts, and so can only be formed if learners are already having the primary concept already. So when you are teaching, we teach primary concept before we teach secondary concept. So you don't go and teach shapes, but you start with specific. This is a triangle. What is a triangle? 3-sided figure. Then we give a lot of example, both the real life example, objects in our everyday life that are triangle. Then we pick an example of 4-sided figure, quadrilaterals, and we show. Then all of them together before we tell the child that they are shapes. They are all shapes. The same thing, this is red, this is white. So the child should be able to identify individual colors before you don't just pick red and say it's a color. But red is a color anyway. But this is red. Let them be able to identify individual one, then they will be able to understand the secondary concept. So what he's saying is that secondary concept depends on other concepts, and so can only be formed. We are talking of secondary concept, can be only be formed and understood by the children if the learner has already formed these primary concept first. So that is why in mathematics we teach addition before we teach multiplication. The same thing, multiplication, division can become a secondary concept as a result of subtraction. Let me ask you, why division is also a secondary concept? 12 divided by 3. What is the answer? 12 divided by 3. Deborah Otaben, you are welcome.
Sir, it's 4. It's 4.
It's 4. Now,
yes, please.
Let's take 12 and take 3 from it. What do you get?
9.
9. We have done one step. Let's take the 9, take 3 from it. What do you get?
6.
6.
6.
We have done second step. Take the 6, take away 3 from it. What do you have?
3.
We have done the third step. And finally, take the 3 and take 3 away. How many do you get?
0.
0. How many times did we subtract the 3 from the 12 before we got 0? 4 times.
4,
so
yeah.
we repeated subtraction to also do division. So division can also be a concept where we have already taught the child subtraction, so that the child can use subtraction to understand division. Now, because of this, we also put, apart from primary and secondary concept. Okay, Otabel, Deborah, which center are you from?
Swedro.
Oh, okay. So you're also from
Yeah,
Sweden.
Swedro Secondary School.
Police are not joining. Why?
Only one is online.
Yeah, I know.
I'm trying to reach the rest.
So what is happening that we are far behind? We are not getting you to join our lessons.
So I'm trying to get in contact with them.
Okay.
Thank you.
All right.
Say. So please,
Yes.
Can we reschedule over the week so that we'll be able to cover up? Or
Yeah, provide. Yes, we can do that. We can do that. I want us to, once we get everybody on board on the group, we will agree on a day. I will take you through maybe another 2 hours. And next week
Okay.
too, we will meet, because next week is not supposed to be a formal meeting, but because we have mixed two already, we'll find a
yeah,
way to do it. I will
to
do that
cover
for
up.
you.
Okay.
Thank
Yeah, I will
you.
do
Thank you
that.
very much.
Once what is needed is for us to be able to start. When we start, we will find different days to meet. When we all agree, that is okay for me. That one I don't have problem.
God don't bless you.
So we have, apart from primary and secondary concept, we also have lower order and higher order concepts. In fact, when you check very well in your model, it's saying that when we focus our attention merely on the common properties of a group of objects, we are doing abstraction or extraction, or pulling out or abstracting the common property. The result of this mental activity is what we have agreed that it is a concept. So concept is where the child is abstracting or pulling out common thing from different objects or different example. The common one he's seeing is the concept. So concept is the mental image we form about something, or the mental picture you form about something. So when we say two, what do you have in your mind about two? So two is not a symbol that we write, but two is from quantity. So go and bring 2 oranges. If the child can see so many oranges, count 2 and bring it. The child has grabbed the concept of 2. But not the child who can write 2, and you write 2 on the board. It doesn't mean the child knows 2. So when I say, go and bring me 10 oranges, and the child can go to the room, count 10 oranges, and bring it to you, this means the child has formed right concept about it, because 10 is a quantity. And he has been able to count. When you read that quantity, he's bringing them to tell you that I understand 10. But when the child brings it and it's not up to 10, the child doesn't know 10. And that is where the child doesn't know the concept of 10. So I have a group of objects, shade, colors, and I say, go and bring me the blue. When we were teaching the blue color, the image or the mental picture the child formed in the mind, so that the child can always remember that this is the blue color. The child has formed the right concept. But they are there, go and bring blue. And the child bring blue, but the child is not actually forming the mental picture of the blue. It is say, cha-cha. He was able to just get the 3. And he was speaking one, and he had brought up, and the blue may not mean that the child has gotten the concept of blue. Now, what is lower order and higher order concept? So the concept, the result of this mental activity is what we call the concept. They said concept involves more stages of abstraction than the concept color, like attribute. He said the concept attribute involves more stages of abstraction than the concept color or shape. So attribute is more abstract concept than color and shape, even though color and shape are secondary colors. But when we say attribute, it constitutes so many things. For example, common word of attribute is features or the characteristics. So if I say describe, assuming you know somebody, and I say describe the person, you see that you go beyond just color or just the shape and talk about so many things. So attribute become a higher order concept than just a color. Color is one of the attributes. I hope you get it. The shape,
Yes,
either
sir.
is this, become also one of the attributes. But when we say attribute, we are combining a lot of even the secondary concept. That's why, so similarly, color is also become higher order than red or than blue. So you see that the red, blue, green, white put together to form color. So when you are talking of blue, when you are talking of white, and you are talking of color, is higher because the color also take more of these things. When you break color, you get different colors. But when you break red, you won't get anything. So red become the lower order concept than color. And color also become a lower order concept than attribute. Because one of the attribute is color. And one of the colors is red. So red is smaller than color. Color is smaller than attribute. So when we talk of the difference between the lower order and the higher order, all that it means is that the lower order becomes a primary concept because you can't break it again.
Sorry, please mute yourself.
Result, you are welcome.
Thank you, sir.
Please, which center are you from?
Please, Swesco, Swedish Secondary School.
All right. So now, Swedro, we have 3 people joining. You are welcome.
Yes, please. Thank you, sir.
So we are looking at the unit 1 and we are looking at concepts. And I've said that concept is the mental picture we form about something. In mathematics, we teach concept. So when you are going to teach any topic in mathematics, for example, sets, and you are teaching the child set, the child should get the concept of set. So you put objects in a group and you say this group is one set. Then you put chairs in another group, it's also a set. You put ... in a group, you say it's a set. You can combine like spoon, fork, knife, and you say this is also a cardinally set. This is also mathematical set. So the child will see that a set is not just one thing, but when you collect a group of objects and put them together, it's a set. So a set is just a collection of objects of the same property or they have the same attribute. And we say we have primary concept, secondary concept. And primary concept are the concept we obtain from our senses when we interact with the environment. And the second, for example, 1, 2, 3. All these things you can use your senses. When I say there are 3 orange, use your eye to see that there are 3. When I say something is bitter, use your taste, sense of taste, tongue to check. Either. So when you put the primary concept together, 1, 2, 3, we say the common name is called number. So a number is an example of secondary concept, while the individual numbers are primary concept. When it comes to color is a secondary concept because within the color we get red, yellow, blue. So the red is a primary color, yellow is a primary concept, white is a primary concept. But when you put all these things together, we give one name called color. Then the color becomes primary concept. And we are saying that we have lower order and then the higher order. So color is a more abstract concept than red. Green, yellow, and shape is also a more abstract concept than rectangle. Rectangle is one of the shapes. Triangle is one of the shapes. Circle is one of the shapes. When you put them together, we say shapes. So the shapes is a secondary concept, and the circle is a primary concept. So when we say higher order concept, they are higher than the primary concept. So normally we say that concepts that we are called the higher and the lower order are depending on the nature of them. So normally we say primary concept are the lower order concept. And then the secondary concept are most of them becomes also lower order. But the attribute, when you put them together, so at the latter part of your model, it says similarly, color is a more abstract concept than red, green, yellow, and shape is also a more abstract concept than rectangle, triangle. So this concept does form a hierarchy in which the term higher order and the lower order concept or relationship are formed more abstract and less abstract. This means that secondary concepts are higher order concept than primary concept. Therefore, When I give you red, white, color, number, and I say which of them is higher order, you pick the secondary concept as higher, and you pick the primary ones as the lower. We notice also that the secondary concept, color, shape are lower order concepts. So we can have, even those shapes, colors, numbers are secondary, they are higher order. We can also have another higher order than them. And that is the example we use, like the attributes. And that is it. So if you come to the self-assessment question, it said, using 3 examples each, distinguish between primary and secondary concept. Can you help me to solve that question?
Using 3 examples, distinguish between primary and secondary colors. A concept.
Yes.
I would say under primary concept, we add up 2 different numbers to get secondary concept.
Okay. We add 2 or more, combine 2 or more primary concepts to get secondary, not number. Example is using the individual numbers, like 3, 4, 5, 6, combining them to form another concept called number, which is secondary. Good. You can use shapes to form primary concept, like triangle, circle, rectangle are all different things. When they come together, they form shapes. So shape is a secondary concept, but triangle, rectangle, circle are primary concept. We can also use the different colors like red, blue, green, and those things. Thank you. And you should be able to explain the higher and then the lower concept. Now let's come to mathematical schemas and their functions. We have another property we need to understand. We have mathematical schemas.
Identifying and explaining what mathematical schemas are.
Thank you. Continue. Continue.
Please, I should read.
We are looking at the objectives. So read the 3 objectives there.
Okay. Identify and explain what mathematical schemas are. Explain the function of mathematical schemas and state their application for teaching.
Okay. So we want to look at what mathematical schemas are, which is also very, very important for us in our discussion. So what is mathematical schema? What is mathematical schema? Any idea? We say schema. So when we learn, part of our brain is for memorization so that you can remember things you learn. So while we are learning the concepts, then part of our mental faculty or the mental structure that organize the related concepts, like it will tell you this is a square. So that anytime you see a square, the concept square is there. So it organizes concept for you.
Okay.
Different concept, it does the organization in your brain or in your mind or in your mental faculty. That aspect is what we call our schema. So when we read, it said the schema is the part of the mind used to build up
the understanding of the
topic. So when we learn, there is a part of our brain or our mind that helps us to understand anything that we learn. It is a cognitive, and so when we say cognitive, we talk about mental structure that has to put pieces of the knowledge we are learning together. That is the concept. Well, what we are learning is a different concept. So I'm learning water, I'm learning air, I'm learning this. So that part of the schema is supposed to do organization and reorganization of the thing so that I will not forget things I'm learning. So that when I see triangle, which is a three-sided figure, and I see another 4 objects, I will not forget the 3 and pick only the 4. So it is organizing them so that at every point in time, you will be able to understand all the topic that you are learning together. And that aspect of the brain is what we call a schema. So if you come to the diagram there in your model, set P and set Q, there are different objects there, but this is matching them. So the child is matching 1 to 1. And this 1 to 1 corresponding is helping you to know that the quantity of objects in set P is the same as the quantity of objects in set Q. And that is a schema doing that organization for you so that you'll be able to match and say that they are the same. If you come to the next diagram, there are different quantity there. But you see that you may not need to match. This one you cannot match. But your ability for your mind to tell you that maybe set N has more object than set N tells you that the schema has do the reorganization. So it said that an intuitive qualitative corresponding schema involves learners making an intuitive. We don't need to always count something before we know that one is, or I don't need to weigh you or use a tape to measure your height. If I see 2 people, I should be able to, my mind, my schema should be able to tell me that this person is longer than this. I don't need to use a tape to say that you are 15 inches. Let's say 15 centimeters. You are 20 centimeters, therefore you are longer than the, but with my eyes, intuitively, my eyes, through my schema, you'll be able to tell me that without measuring you, you are longer than this, and you are also shorter than this. And those things we do, for example, the first example, you see that we are matching before we're able to. But if the schema is working, with a twinkle of an eye, we should be able to say that these 2 objects are the same. So the second example, you say in the diagram, a child using the intuitive qualitative corresponding or the schema will determine that M seems to have more elements than set N without counting them. And when we do that, it means that your schema is helping you to understand the things you have learned. The first one, we measure or we correspond them 1-1 and we saw that they are the same. But going forward, you don't need to be able to compare 2 objects, always go there and match them before you need to know one is bigger or more than the other. Intuitively, your schema should be able to help you to do that. So explaining the functions of mathematical schema. 1, the main function is helping us to do 3 things. 1,
integration of existing knowledge.
Good, wait. It helps us to integrate. You see, you have, okay, I'll explain that. Go to the second one. We'll come to the explanation.
Acting as a tool for future learning.
Thank you. And the third one.
Making of understanding possible.
Good. So what the first one is saying is that when your schema is working very well, it gives you the opportunity to integrate exit. You see, as we are learning in our education, we are learning different things. But the schema should be able to add what you have learned already to the new things. For example, if I've learned 3-sided figure, which is called triangle, and another time I'm going to learn 4-sided figure, the schema should be able to integrate the two. That I don't need to forget the 3-sided figure before I will learn the 4th, but I will use the knowledge of 3-sided figure to be able to continue my 4-sided figure. So it said a schema is integrative in nature. It helps us to identify one object as belonging to a class of other objects. And that is very important. We think of a concept as itself and a class it belongs to. So for example, if I say even numbers in mathematics, and I say 2 is an even number, 4 is an even number, 6 is an even number, then the child should be able to use the schema to know, if you understand what a even number is, dividing objects equally without a remainder. Then when I give a child 6, 10, 12, 14, 17, you should be able to tell me which of them is even, which of them is not. For example, a number is by itself of a different example of numbers. So the class to which the number will fall depends on every individual experience. So an odd number, even number, a prime number, they are all numbers. They are all numbers. So the child knows that 1, 2, 3, up to infinity are numbers. We are taught that concept of numbers. But the child should be able to know that even numbers are different from prime numbers. Prime numbers are different from odd numbers. So the schema should be able to integrate that they are all numbers, yet they are differences. So that when I say even number, you don't tell me that because it's a number, every number is an even number. So the child's ability, the brain, the mind's ability to do that part of schema, the schema helps us to do what we call integrating the existing knowledge. So that when I learn the even number and now I'm coming to learn the prime numbers, I will not forget the even number, but I can integrate the even number and the prime number so that I know that they are all numbers. I know numbers, but I can distinguish even numbers from prime numbers. Is my explanation clear to you?
Yes, please.
But then we see that in teaching, we say we learn from known to what?
Unknown.
Well, we learn from known to
Unknown.
unknown. And so when we are teaching, we start from what we know and use it to learn new things. That's why in every classroom, when you are teaching, we say use the students' previous knowledge. Link it to what they know already. The reason is this. The child should be able to integrate the existing knowledge to the new knowledge so that what you know already will help you to understand. For example, when you are teaching a child subtraction, but you have taught the child addition, and the child knows that addition, when I add two numbers, is moving to become bigger. Now you are going to also look at subtraction. So the child's ability to also know that when I'm subtracting 8 minus 2, then the number answer becoming smaller than the 8. But when I say 8 plus 2, it's rather becoming bigger than all the numbers. So the child's ability to use the knowledge of addition to learn the knowledge of subtraction, he has to do what we call integration. And that is, if integration is not there with the concept and then with the schema is not helping us to integrate, the moment you learn first thing and you go and learn another thing, the first one will run away. You don't remember it again. But we need to connect them so that the child can make differences and similarities of what we are learning. So the paragraph, there is a concept can be interrelated. When we are faced with a mathematical problem, we begin to bring into focus all past experiences that can be integrated to solve the problem. So you bring addition in, you bring subtraction in, you are interrelating them, you are bringing them together. So the more of the other schemas we have available. So we are schema for addition, we are schema for subtraction. So you see the same question, there will be addition, there will be subtraction. So you are interrelating all the schemas together. So the better our chance of understanding the thing. If you are able to bring all the schema of the different things. So you have schema for addition, schema for this, schema for this. So the concept rectangle is embedded in the concept of parallelogram. Yes. So when you teach rectangle, it's a four-sided figure. All the sizes, opposite sizes are equal. Angles are 99. When you come to parallelogram, the angles are not like that. They are even now, you have different property, but you see that all the property of rectangle, you can find them in parallelogram. It's like a square and rectangle. If you teach square and you're going to rectangle, you see that all the properties of square are in the rectangle, but not all the properties of rectangle are in the square. So you need to be able to integrate them And so the concept of rectangle is embedded in this, and that of parallelogram is also in the quadrilaterals. So a schema helps to show the interrelationship among all related concepts, and that is what we call interrelation or integration. The second point is that a schema is also good for further learning. When you teach numbers, and the child has good schema of addition, for example, 2 plus 3 is 5. 3 plus 4 is 7. Now, in future, we will go and say 3a plus 4a. The schema that the child has built already should help the child to learn the further thing. We have added, at first, it was 3, just 3 and 4. Now we have said 3a and 4a. So the schema of the addition you have learned should help you to understand the new one by adding up. So it's also, we get the 3 plus 4, which is our 7, and the a and a is the same object. So instead of saying 3 mangoes plus 4 mangoes, then you say 7 mangoes. So the a that has been added is just the object, but the 7 remain. So the schema you know already is helping you to do further and learning. So knowledge of properties of rectangles will help you to know the area to find that of triangle. Because if you check, when we come to the actual teaching, you see that before you teach area of a triangle, the child should know rectangle first, area of a rectangle. It's because when you divide rectangle into 2 through the diagonal, you get 3 triangles. 2 triangles. So if the area of a rectangle is length and breadth, and one rectangle, you get 2 triangles. So that then triangle, area of a triangle becomes half of the area of a rectangle. So we use that schema to help us to understand and making understanding possible. So in actual fact, when we have schema help us to understand everything that we learn. And this bring us to the understanding called assimilation. And there are 2 other terms we are going to learn. Assimilation. And then in concept, if we mention accommodation and assimilation, let me use the third point, making us understanding, to explain these terms. So if you come to the third paragraph, it says schema are developed by the process of adaptation, which can take 2 forms. So to adapt, there are 2 forms, assimilation and accommodation. Please understand these 2 terms for me. Assimilation and accommodation. We ask you in exams these 2 concepts. When we say assimilation of a schema, it occurs when existing cognitive structure require a little modification to include the new ideas. What it means is that what you have learned already, and you are going to learn a new thing, the new thing doesn't confuse the old one. So you can add. So it's just a matter of adding up without bringing any problem. For example, when I say addition, and the child knows that I am adding means I'm putting it together. And I'm going to teach them subtraction. The concept of subtraction is addition. You see that I can bring addition. So in addition, I'm only taking away something. So if I have 5, I'm taking away 2. If I'm adding, I'm putting them together. This, you can assimilate. I've learned addition. I can assimilate subtraction without creating any confusion. So in your book, he's saying that assimilation of a schema occurs when one existing cognitive structure, something you have learned already, requires a little modification to include into the new idea. So it's just a matter of bringing new something small to understand the new one. On the other hand, if no relevant schema exists, new behavior sequences are built up through experimentation, instruction. So Piaget called this process accommodation. I will explain accommodation again. The mechanism by which a schema is assimilated or accommodated into one's cognitive structure is an operation. And so let me just make the two terms simple for you, because the book has not given you the clear concept. Now, I'm saying that if you are doing assimilation, for example, you know a rectangle, and you are going to learn other concept, which is shapes. So I know rectangle is four-sided figure. I'm going to learn other, like pentagon. It's also five-sided figure. So it doesn't change my understanding of rectangle. Because when I see four-sided figure, it's a rectangle. When I see three-sided figure, it's a triangle. So when I bring triangle, when I bring pentagon, octagon, and those things, no problem. Because the two things are not conflicting, I can assimilate, add this one, and it will not change my idea for the second. But when it comes to accommodation, this is where there is a contradiction. So you change a schema to fit in the new one. For example, learning triangles can have different angles at the triangular schema. Let me give you a typical example. So you in the accommodation, you do adjustment before you can understand the new thing you are learning. But in assimilation, you don't do adjustment because there are no difference. So you just add the new schema and you get it. So when you are learning equilateral triangle and you know triangle already, schema of triangle will help you to understand that when there are three-sided figure, every three-sided figure is a triangle. Now I'm going to learn equilateral triangle. When the three-sided are equal, so you see that even though I understand triangle, I'm only trying to say that when they are equal, when they are not equal, they are not equilateral. It doesn't change conflict. What I know, when all the sizes are not equal, it's Scalene triangle. It doesn't change my idea. But let me give you another example. So that one you are only assimilating. But let's see another example where you are learning additions or multiplication. Let me use multiplication. Let me use multiplication. When you multiply 2 by 3, what do you get?
Sis.
Thank you. When you multiply 10 by 2, what do you get?
20.
When you multiply 3 by 4, what do you get?
12.
So if you are teaching the concept multiplication to a child, what is the child forming in mind? What the child is forming is that anytime you multiply, the number becomes big. 2 times 6, 12. 2 times 3, 6. You see, the two numbers combine to give you a higher number. So in every multiplication, the child has formed a concept that the moment you are multiplying, what are you getting? You are getting a bigger number. Good. Now let's come and do another multiplication when it comes to integers. And I'm multiplying -2 by +3. What will I get?
You get 1.
No, I'm multiplying.
You are
Negative
Okay.
2
negative
and
6.
negative
Say
2.
negative 6.
Negative 6.
Yes,
Is it
ma'am.
becoming smaller or bigger?
Smaller.
Smaller. You see that
Yes.
this one I cannot just add because this time is conflicting with the knowledge I know already. The knowledge I know already was that whenever you are multiplying, You are what? Making the numbers becoming bigger.
Big, yeah.
But this time, when I'm multiplying, the number is becoming what? Smaller. So
Small.
I'm learning different thing. This time, I need to adjust my knowledge already. So this one, you don't just add up. People add up, you'll be confused. So you need to adjust, accommodate. So in accommodation, all that we are saying is that in accommodation, you do adjust the schema so that you can bring the new one to fit. So accommodation, changing schema. So the already existing schema, which says that when you are multiplying, the numbers become bigger. You need to change so that it will fit into the new information. And that is how accommodation comes in. So the difference between assimilation and accommodation is that in assimilation, the already existed schema and the new schema, they don't conflict. So you add it up and you are okay. So when I'm adding, I am putting them together. When I'm subtracting, I'm taking away. So when it comes to addition, do this. When it comes to, but I am multiplying these numbers. But this time, it's giving me higher number, bigger number. This time is giving me. So when I see negative, one negative, one positive, the number should become smaller. This is why I'm accommodating that to the fact that when they are all positive, the number becomes a bigger number. So it's a different concept, but the same multiplication I'm using is changing the ideas. And once it's changing the ideas, I have to be careful. I don't have to just add up. If I add up and say that, okay, when you multiply numbers, it also becomes smaller. Then I am defeating the first schema. That's why you need to accommodate them. So we need to understand these things very well. Now let's come to the 3.10. State the implication for teaching of this schema. So he's saying that teachers can play a significant role in providing physical and psychological experiences of their learners. The quantity and the quality of experiences provided by the teacher for learners can bring their conflicting ideas into balance. And so this is a process known as equilibrium. So when you reach equilibrium, like I was saying, accommodation, when the child is able to combine that in multiplying numbers, which are positive numbers, it will always become a bigger number. But when I'm multiplying one positive and one negative, it becomes a smaller number. You have, and it will not conflict again. You understand the two concepts clearly. You have reached what we call equilibrium, a state of no confusion. This is what we call equilibration. Teachers therefore need to provide learners with mathematical experiences in a form that will assure the student to understand. So when we are teaching mathematics, please let us help our children to understand the mathematics we are teaching. That's why this is the first topic. So that when we come to addition of whole numbers, multiplication, we help the children to understand. So this means that primary school learners will learn mathematical concepts by manipulating materials and observing what happens. So they need to touch objects, concrete operational state. So we need to help them to touch objects, manipulate objects, and experience them. A teacher will provide a kind of concrete experiences that will facilitate learning. So when you are teaching in lower primary, especially, please use the material. When they are counting, let them see 3 objects here, 5 objects here. If you want them to understand 5, don't do it in abstract. Let them see the 5. And don't use one example like we have said. 5 oranges, 5 pens, 5 mangoes, 5 books. Then they see that this is 5. Don't choose 5. Just say 5 and go away without them seeing 5. And when they are even seeing the 5, they should see different examples of 5 so that they form the correct concept in their mind. So that is it. So explain briefly what a mathematical schema is and describe the 3 functions of mathematical schema. That is accommodation, classification, and then equilibration. How children form concepts. That is the 3rd thing we are doing. Ways learners develop concepts. And the first thing is discrimination. The second thing is similarities and difference. But when I'm teaching, I've talked about these things. So please listen. We are talking about how children form concept. There are 4 things we should learn here. And the first one is discrimination. So if somebody tells you you are discriminating, how do you understand? How do you understand discrimination?
You are being
Meaning
biased.
you are being
You are being
biased.
partial.
Okay. So if we say learners learn concept first through discrimination, and what does it mean to you?
It says learners interact with their immediate environment and begin to discriminate. That is, they manipulate materials, find out the objects bearing common properties and classify them into groups.
Okay. So when we say discrimination, in learning concept, I've told you that concept is formed when they see something in common. But things, when they interact with the environment, they are able to bring things that are common. They are also able to bring things that are not common. They discriminate. This is totally different from this. So it's saying that learned behavior in recognizing objects is based on classification of previous experiences and the fitting of their present experience into one of these classes. That is using past experience to understand the new one. That is why in KG, early childhood, when we say sorting, we can give them, so the next topic we talk about it, give them different bottle tops. Then the child will know that common thing is that they are all bottle tops. But there is a discrimination. You can discriminate them by their colors, like malt, Fanta, Avaro. When you get their bottle tops and put them together, the child can do discrimination. Know that Fanta one is orange color. Is it orange color or orange color? So you put them together. Coke is black. Sprite is green. So the child is sorting using colors to discriminate. So he's bringing the differences. But when it comes to concept formation, you will see that either you are putting the green quantity of 2, the one with the orange quantity of 2, you are forming the same thing. Common thing is that the quantity is 2. And so in discrimination, we do classification or grouping. So common, having the common, that's why we use the word abstraction. You are bringing things that are common to give the name, and that common thing is the concept. So check something. When I told it, okay, when it comes to sorting, I'll talk about it. In this regard, learners continue to look for and describe the similarities and differences among the examples before them. So like I say, we will give them bottle tops. If you talk about the nature of the object, they are all bottle tops, so they are similar. But then there are other things that bring the difference, and that could be the shape, that could be the color. So from learner's past involvement or experience, he or she abstracts certain invariant properties which persist in his or her memory together. And so apart from apart from discrimination, another thing they use to learn concept is similarities and differences. So they can say in a sorting, we say, put the shapes together, those that are alike. Now you see that we can have triangle, small triangle, medium triangle, bigger triangle. If it comes to the shape, the child will put all of them together because they are all 3-sided figure. But when it comes to the size, probably the small triangle and the big triangle, the size are not the same. But you may have a circle which are the same size, are the triangle. So in terms of size, the child will put them together. So at every point in time, it is something you are looking for. And that brings, so either you can look for, so I say, color, use color to sort them. Then you understand the color, even though they may have different objects. In terms of object, they are not the same, but in terms of color, they are the same. You are putting them together. Then abstraction, that's where you are able to do what I call pulling out the common thing. So abstraction, and let's abstract in concept formation. Here, the learner begins to abstract the main or invariant properties of example given. An abstraction is a mental representation of a mathematical object. And to abstract means to extract what is common. So when we use the word abstraction, you are bringing what is common out from the concept. And the final one, they will be able to learn what we call generalization. So the learner draws some general conclusions. Oh, all these things are white color. Even though the objects are not the same, but the child is able to tell you that they are all this because he's generalizing based on a characteristics or a feature. So implication to the teacher, concept have to be formed in the learner's own mind. Please listen to this point. Concept. You, the teacher, cannot put concept in the child's mind. So concept has to be formed in the learner's own mind. The work of the teacher is to bring different examples for the child to be bringing, to be able to abstract the common and form the concept in the mind. So if the child understands the concept of yellow, it is the teacher who is bringing yellow, two different yellow objects, and the child will form in the mind that this is yellow. What we have to do as teachers is to help along the learner's learning process. It is the process of learning that we will bring the objects and the materials together, but not to do it for them. You can't do the concept that this is yellow, fashion with trim is yellow. You can't do that. It is you bring materials for the child to be able to abstract on their own. So if the child doesn't understand that addition is putting objects together. So if I'm adding 3 plus 2, I will count 3 objects. I'll count another 2 objects. I'll put them together. I'll count again. The quantity I have is 5. When the child can go through all this process, then you, the teacher, have done the process well for the child to abstract the concept of addition. But you cannot force the child that, so 2 plus 3 and you have written 10. If you are not careful, you kill the child. You beat the child because you cannot put that concept in the child's mind. The concept of addition is a process. What the teacher can do is to bring the materials available in the classroom, take the child through the process for the child to form his or her own concept of addition. That is it. So that is why we say, in other words, the teacher, you have to act as a facilitator in the learning process for proper formation of concept by the learners, but you are not going to form the concept for the learner. So the work of the teacher is to facilitate the process. Also, as teachers, we must ensure that learners learn their early mathematics concept by abstracting from concrete experiences. So bring the material. So when you are teaching numbers, don't just let them count the numbers. If you say 2, let them see different 2 objects. This is 2, this is 2, this is, they are all objects. The child is touching them and cutting the process of abstraction so that the child will see the difference or the common thing involved in becoming aware of something common among them. And that's why you say you have helped the child to do abstraction. If a learner does not have available in his or her mind the concept which provided these experiences, he or she cannot form any concept in the mind. Take note. So if objects are small, we can bring them together physically. What we mean is that when you are teaching concept of numbers, 1 up to 20, you can bring them together and let the child count them. But there are objects you are teaching. You can bring them to the classroom. For example, if you are going to teach a cat, it doesn't necessarily mean that I'm going to bring a cat to the classroom. or dog or elephant.
Literally.
You want a concrete object. That's not what you are saying. But the ones you think they are small things that you needed to be brought into the classroom, you can do that. So that's why we are saying that you can bring them physically. If they are not easily moved, we can arrange a mental grouping of pointing. In this way, we can help the learner to find out the meaning of him or herself. This enables the learner to achieve an expression. So that is why we can also arrange for the child to see either the picture, the image, or something that the child can form it in their mind. So when I started the lesson, those who were there, I said that when you are thinking of the United States of America, you want the child to have a concept of United States of America, for example, New York City. You can't bring New York City to your classroom. You can't. But you have to create something for the child to form the right concept about New York City, but not to bring New York City, that this is New York City, like you can bring some other objects in your classroom. So to form a concept, a learner requires a number of common experiences relating to the concept. So please, let's take note of that. You need to bring common examples relating to the concept. The learner finds the common property. So for example, if you are teaching red, like I said, you have to bring different red colors for the child to now see the common thing. So red said, it's, you know, the way some of us teach, because we don't allow children to form abstraction. And you give only one example. For example, you are talking of red, and you bring phone. And show to the children, this is red. Some of the children think that the red is the phone. So when you say you see phone, you say red, because they have formed wrong concept. But when you bring red phone, red pen, red book, red duster, red shirt, red bag, and you say red, the child will see that red is not any one of them. It is the color he's seeing common to all of them. And this is how we form concepts. And this is very important. Let me just quickly, because this unit 1 is more of reading, not calculation or not anything. So before our time, I have a lesson at 1:30. But before that, let me talk about section 5. The psychologists can be put into 2 categories. We are the behaviorist learning, the way people see learning, because children are learning mathematics. And this is you have learned them in education. Psychologists can be put into 2. We have what we call the behaviorists and developmentalists, which we later call constructivism. When we talk of the behaviorists, they see learning as observable behavior, change in behavior. When learning has taken place, they want to see change, observable change you can see. You couldn't do this, but now you can do it. That means learning has taken place. And they believe that learning occurs through stimulus response reaction. When we say so, we are psychologists like Thorndike, Pavlov. They believe that learning occurs through stimulus response mechanism. Give it to me, I will take it. Give it to me, I will take it. When I teach, without the teacher, learning cannot take place. That's all. So they believe that teacher is going to help the child to learn. What it means is that when the child is coming to learn anything, the child's mind is empty. There's nothing the child knows, unless the child will only learn what the teacher has given to the learner. They believe that teachers are the main important thing in learning. Without the teacher, the child cannot learn. So they believe that the teacher is the center focus of learning. And the child is going to classroom as passive recipient of the knowledge. Sit down, listen to the teacher. Whatever the teacher gives you, take it, and you have learned. When you're able to do what the teacher has said, your learning has taken place. If you cannot do it, learning has not taken place. Without the teacher, you can't learn. So your mind is called tabula rasa. So if you read the book, it uses the word tabula rasa, meaning the child's mind is an empty pot. When the child comes to class, he's bringing a pot, the mind is empty. But is the teacher, either the pot will be filled or not, depending on what the teacher give you. So it's the teacher who is going to fill the pot for you. So the teacher becomes a main important in learning. Without the teacher, learning cannot take place. They also talk about reward and punishment. They said that when you learn and the right or the desired attitude is shown, you reward the child. If the undesirable attitude is shown by the child, it means learning has not taken place and the child must be punished. So they brought about the idea of reward and punishment in learning. That when I teach you something and you're able to produce it back to me, let me reward you. For example, I will praise you in a form of praise. Let's clap for him because he has been able to do well. Now, when you didn't do well, we will not clap for you. That's a punishment. Their punishment is not go and kill the child like the corporal punishment. They believe that, okay, I've given you all toffee, those who got it. Those who didn't get it, you didn't get toffee. It's a punishment. And next time, because you want to get the toffee again, you will learn well to get the right response. Those who didn't get it and didn't get toffee, next time they want to get the toffee again. They also want to get toffee. They will learn. And that is their belief. So they believe that learning is several rounds. And when you hear that it's an empty, the child's mind is empty. That will be filled by the teacher. So the behavioral theory is simplistic, provide instructional guidance, allow for short-term progress, and less itself for accountability pressure. It allows children to produce back what the teacher has done. So without the teacher, learning is not taking place. But the other group we call the cognitivist theories or the developmentalists, or what we now call constructivists. They believe that, for example, Jane Piaget, Jerome Bruner, Jordan Deans. Please read your book well, because sometimes in the objective we ask you, which of the following belong to the cognitive psychologists? Or which of the following belongs to the behaviorists? So John Locke is the behaviorist, Thorndike is behaviorist, Pavlov is behaviorist, B.S. Skinner. But when you come to the psychologists called the cognitivists or developmental, we have Jane Piaget, which you know him very well, and Jane Piaget, Jordan Deans, Jerome Bruner, Richard Sken, who developed concept, are all there. So cognitive believes that for them, they contradict with the other group. They believe that children can learn on their own without the teacher. If the teacher there, the teacher serves as a facilitator, as a guide to support. But the children construct their own learning. The work of the teacher is to construct a conducive learning environment. And when a right environment is created, learning can happen. So children's mind is not empty. They know something, but the teacher creates a right environment for them, and learning will happen. That's it. And they are the constructivists. So how learners construct mathematical knowledge? As learners interact with objects, listen to them. And children, that's why the teacher, they believe that teachers should be facilitated by bringing the resources in the classroom. And as learners interact with the object, events, and people in the world, they need to make sense of new experiences in relation to the old ideas and the Piaget theory of learning, as well as those ideas of many other cognitive theories, call it constructivism. So in constructivism, they believe that children can construct their own knowledge when the right environment is created for them. So we have Brunner, Deans, and those people, J. Piaget. If you read, they all talk about the constructivism. So constructivism teaching practice help learners to internalize and reshape. And they believe that when you help the children as a facilitator, creating the right environment, learning can happen to them. So that's the difference. So they believe that children are active in the lesson, but not passive. But the behaviorists believe that children are passive and the teacher is rather active, giving everything. But these people think other way, that you have to make children active, create right environment, and with the experiences they will learn. And this is what we are using in the modern curriculum, the constructivism, that the teacher role is a facilitator, create the right environment, and children will learn. This is where we want to end the lesson for the day so that I can plan for the second lesson. Thank you very much. If you have a question, you ask me. God willing, within the week, I'll schedule a meeting for you so that we meet. As we are now on the same platform, I'll be able to discuss with you. We are arrange. Please kindly encourage your people to join so that we can move smoothly. If you have any question, you can ask me. Please, before today, were you joining any other group? Or
No,
this is the
please.
No, sir. No, please.
Please, I'm Doris. This is my first time.
Okay. So kindly encourage your people to join, because we will take our time, find different time to meet so that you understand them well.
Okay, please.
All right. Thank you very much. Enjoy your day, and we will find time to meet again.
You're welcome.
Okay.
Thank you.
Thank you, sir.
Auntie Norris.
Sister.
Thank you.
And the school phone go saying our friend. Dear ba said it.
What's the Swiss Congo thing?
I wasn't hearing others.
Me sure man tell me any kasa apart from one I yeah kasa another.
Oh, okay.
Charme was na me ne baby a ọwọ mom. This is ebisa no.
Hello,
Eh.
Auntie Salome. Hello, Auntie Salome.
Ani ọkọ na. Ọkọ
Ebe se
iso.
we fi so.
Waso.
Hello.
Hello, Auntie
Hello.
Salome. Good afternoon.
Good afternoon. Oh, my network dropped.
Oh, okay, okay.
Yes.
But yeah, we are from Swesco Center. Where from you?
I'm from Temasco.
Oh, okay, okay.
Please, there's a little challenge I'm having.
Okay.
I'm studying early childhood education.
Uh-huh.
Anyone from early childhood education?
We are all early childhood,
We
and we are
are
also
ready
facing
to.
a lot of challenges.
Please look at this. You see on the portal,
Uh-huh.
on the portal, the code is the model code, the mass code is E322, right? But then in Temasco Center, they gave us a different maths book. A different
Okay.
the title is Method of Teaching Basic School Mathematics 1.
Oh no,
Okay.
that's not for us. It's for
It
level
must
200.
be method of teaching primary school mathematics.
That is for
Yes.
early childhood.
Yes.
Yes.
I was asking my other colleagues, they are saying no, sometimes it does changes. I don't know.
Okay.
Like, this is my number.
Auntie Salome, have you gone through the model? Do you have the
With
same
that
content
model,
as you are using?
not at all. With that content, it is number and numerical the first content is pre-number work. Pre-number work.
Then it's not for us. It's not ours.
Ours
Hmm.
is concept. The first page is concept.
You are doing early childhood level what? Level 300.
Yes.
Me too, level 300. I'm telling them they are not understanding because that was
It's
what
different.
they were giving to us. So they gave us hard copy.
Oh, even for ours, we weren't given any hard copy. It's soft copy.
Ah.
It's soft copy.
They
So
gave
the
us
So
only
if
thing
you
you can
remember,
do is
the hard one was there, but we didn't take them. It is not for us. That's why I didn't pick them.
the hard one they
Mhm.
gave us is pink. The cover is
Yes.
pink.
The cover
Yes,
was
Yeah,
pink.
it's the same.
yeah, but
Yes,
it's not
yes,
for
yes.
us.
It's not for us. It's not for
So they
us.
didn't give it to you, eh?
We
Yes.
didn't
Yes.
receive it at all.
Hmm. They have shared it to us. So
Hey.
No, you take them back. You take them back.
like they gave it to us like 3 weeks ago. Please,
Wow.
I want to add my contact so that you add me to your group.
Oh, okay. If you continue learning, you will learn something different. Oh, that will
See,
not come to the quiz. Yeah. So
So
you
put
take
that
them
book
back.
somewhere.
Mm-hmm.
I should put that book somewhere. But
Yes.
the
I will
one that
understand.
the teacher was using, do you have a soft? A soft copy.
Yes,
Ah,
yes.
you
So
just
you
put them
just
in the group.
bring out your number, then we
And
send it to you.
okay. Please, what did he say? He said he would join us again.
Yes.
What time? Like
He
within
didn't
the
give us any time. He said he
They
will
not give us
schedule
a
another
time.
time for us within the week.
he should do so. The teacher is good, so that he should help us cover it because it's like
Yes.
we are far behind.
Ah.
Okay.
And
Ah.
they said we'll be having an English class around 3. Another
Okay.
English class.
Okay. You let's have your number. So if anything, you alert us, then we too will alert you.
Okay. You are all in early
Let's,
childhood, right? Level
yes,
300.
Yeah.
yes, the same center.
Okay. Then I will join you to the mass group so that we can be communicating.
Okay.
Okay.
Yeah.
What
All
when
right.
he was ending, what did he say?
He said he will schedule
Qua-
another time for us within the week.
Oh, okay.
Mm.
Thank you. You can also add
Let
your
me see.
contact so that I also write it.
Okay.
Okay. He said a lot of questions will be coming from the
Mm-hmm.
unit 1.
Unit 1. Okay.
Yes. So we should keep reading, especially the names.
The names.
Um,
Oh, okay.
mm.
Thank you.
All right.
So please,
Bye
you
bye
should
to
also
everyone.
add your number.
Bye.
Add your number.
Okay.
Add your number.
Okay. Okay.
Okay, we
Okay.
will do so. Auntie Doris.
Aisha.
Auntie 4 o'clock the Baba do ana.
Uh,
Patrol 4 o'clock
uh,
yet.
Oh, yeah, English.
English.
English. Oh, okay. Me ni
Um,
mo fa mo number mami na me. Na ya ya sebo auntie.
Yes, I have to first name so you who baby am fanfa.
First, one that na yeah, so drunk now.
Baby
Ah,
Yeah.
yeah. Eh,
I said fully. One more year back, we say.
what is that? I won't say what them.
patrol me number no. Are you typing? Hello. Hmm. Hmm? Hello. Hmm?